let's take a minute and talk about that green tree, okay? Let's take a tree. Chunk of a tree with a pith in it. And let's take an imaginary wedge out of this that we can work with for a minute. Okay. All right. Now, what's the tree made of? Straw-like fibers going up and down the tree that's going to feed the leaves. It's the maple syrup, right? So those straw-like fibers carry the water up and down. All right. What happens when the water gets out of the straw-like fibers? They shrink. Death, taxes, and when wood dries, it's going to shrink. You can't stop it. So you just have to understand what's happening with it and try to work with the wood so that you can do it successfully. All right. So the shrink rate is the most stress, and the largest amount of shrink rate is around the circumference of the tree. Okay. Now all varieties of wood have different shrink rates. 8 to 12% is a normal range. So for math purposes, let's just call it that's 10% shrink rate around the circumference. All right. Now from the center of the tree to the edge, it's going to shrink half that much, or 5%. Okay. And what's it going to shrink endwise? You take an 8-foot long 2x4 and you have it kiln dried, it's still almost 8 foot long. It shrinks almost nothing on the end, but it's no longer 2x4. It's going to be smaller. All right. So let's take a bowl and make a bowl. And we'll leave it thick. Okay. And then when it shrinks, it's going to get oval. It's not going to shrink this way. It's only going to shrink this way. So it's going to get oval. And so in double turning, if I want to use something that's going to be round when I get done turning, I have to double turn it. So I would turn this thick, and the rule is usually about 10%. So if I've got a 10-inch diameter bowl, I would leave this about an inch wall thickness. All right. Then after it's dry, 6 months later, if it doesn't crack, and there's some things that we can do to try to help it, but we just have to slowly get the moisture out of it. If I let it dry out too quickly, the moisture is going to get out the end grain pores, and the edge of the wood is going to get dry, and the middle of the wood is going to stay wet, and then it'll arm wrestle itself until it cracks. So we have to slow it down and get it to dry uniform so that the inside dries out at the same rate as the outside. All right, so we wait 6 months, and it does survive. It didn't crack this time, and we put it back on the lathe, and hopefully we have enough wood left that we can get a round bowl out of it. Okay, so that would be double turning and working with dry wood. I normally don't do that anymore because I don't care to work with the dry wood. Okay, let's look at what's happening to the stresses here. Now, the water is going to get outside, going to get out of the wood on the ends faster than it is on the sides because the pores are open. And there's two kinds of water in wood. There's the unbound water. That's the maple syrup we were just talking about. Let's say, I don't know what the starting moisture content is, but the starting moisture content has to get all the way down, and the unbound water has to leave. And at that point, I think a good benchmark would be about 30% humidity in the wood. And then from there on down until dry, whatever dry is, if it's 8 or 10%, we have bound water. And the bound water is the cell structure water, the microscopic pockets of water that's held in the fibers, and that water doesn't get out very easily. Okay, so when a tree is drying, the unbound water gets out first, and the tree really doesn't, the vessel or the turning really doesn't change shape until it gets down to the bound water starting to exit. Okay, so as this wood is drying, it's causing stress, and if we leave it in a log, there's going to be cracks starting on the end grain here, Be cracks radiating in from the side, be cracks radiating up from the bottom. All right. So one of the main things we want to do when we start to work with this wood is to leave the length of the tree long, because we know that we're going to have to waste some of this off in order to get some good wood in the middle that doesn't have cracks in it. All right. Let's think about these stresses a minute. Let's say that we've got a 10-inch diameter tree. Okay. 10-inch diameter. What's the circumference? Pi d, so 10 times 3.14. That would be a little bit more than 30 inches in diameter. 30 inches in circumference. All right. What's 10% of 30 inches? 3 inches. So we would have to take a crack 3 inches wide in order for that tree to come from the humidity place that it started down to dry wood. Okay? That's a lot of stress, right? Normally we don't see a tree with just one crack in it. It's all kinds of little cracks going along, but if we left it long enough and waited until it got all dry, and that would take years and years to get the whole center and everything dry, it would end up to be a 3-inch crack in it. So that's a lot of stress. We have to realize how much stress it is. So it's wanting to shrink in on itself. The pith is there so that it can't. There's wood in the middle. It can't shrink in, so it starts to crack. All right? Remember I said earlier that in order to make a bowl that doesn't crack, we need to go uniform wall thickness. If we have a bowl that's not uniform, let's say we do a bowl again that's got a nice thin rim, but we leave a fat bottom, all right? This wood on the rim is going to dry out quickly. This is going to stay wet. It's going to arm wrestle itself until it cracks. So we do everything right, and we do a bowl that's got a uniform wall thickness, and it still cracks. Chances are that crack was already in the wood before it started. All right? So we want to make sure that that piece, the wood that we use, has enough wasted away.